Important to remember. One, for zero rest mass, particles that include particles like a photon must travel at speed c. Number two, non-zero rest mass particles, for example, say electrons, have a limiting speed given by equation, I don't know, let me call this 3a. Okay, and let me call this equation 3b. 3b. Another important thing to remember, note number 2, energy of the photon is not a function of its speed. Why? Because photons only travel at the speed c. So for example, for a normal particle, a car going 60 miles an hour, its energy is more than a car going at 30 miles per hour, correct? Because it is a function of its speed. Now for photons, what is the only speed that a photon has? Speed of light, right? In that case, the thing that determines how much energy a photon has is its frequency. Let's write that down. So energy of a photon is not a function of speed. It is a function of frequency. So you have seen this written for the energy of a photon. Can I also rewrite this as hc over lambda? Why can I write that? Because c equals lambda f. Speed is lambda f for a wave. So that means f is c over lambda. So this equation tells us higher frequency, higher energy. Lower frequency, lower energy. And this tells us higher lambda, lower energy. Is that true? That's how equations work, right? Because h is a constant, c is a constant. That means E is inversely proportional to lambda. And lower lambda leads to higher energy. Okay, I'm going to ask you one other thing. Note number 3. So for photons, their rest mass is 0. So there is no distinction between total energy and kinetic energy. So whatever the kinetic energy is what its total energy is. Note number 4. So for photons, they had to come up with a completely new statistic in order to define what a photon is. And that was called Bose-Einstein statistics. Whereas for electrons, they obey what are called Fermi-Dirac statistics. These are also called BE stats, and this is called FD stats.